Okay.
This final session is on the topic of a roadmap for the future development of AGI over the next few years and even beyond that. But before launching into that, I want to let our conference chair, Stan Franklin, give an overview of some of the things that were discussed in the business meeting last night, which not everyone attended, which I think was some pretty interesting resolutions and conclusions.
Will this work as well? Well, we had both a discussion session, as many of you were here about, and our main agenda items were where do we go from here in terms of conferences, etc. What do we do by way of a book series or other publications, a journal? Another piece was, how about organizing? Do we want a separate organization or whatever? The general feeling from the discussion session was that we should have a new conference, a conference next year, an AGI-09. In the business meeting, we broke up into working groups, into 3 working groups. One was on the conference. I think it was decided there that the good place to hold this conference, the next conference if possible, was in the DC area because of proximity to funding agencies and things that we can do. Pre-conference workshop, including people. What's that?
The White House.
The White House. Wlodzislaw says pre-conference workshop in the White House. Does that depend upon who's in the White House?
Probably so.
Give it a try. If it doesn't work, I'll hook my laptop.
It may.
Yeah.
Anyway, so there are people that are going to work on trying to put that conference together. There's a possibility of holding it in one of the universities in that area, and people are going to look into that. Or otherwise, we can find hotels that will do it. There was also some talk of more special purpose workshops, and my guess is that's going to come up again in this morning's discussion. The publications piece, there was considerable discussion of a book series, and it seems that there's almost agreement that we might go with Atlantis. I wanted to say Atlantic, and I knew that wasn't right. I was trying to get it right. But with Atlantis, as Kai's been pitching to us. And there was also considerable discussion of the journal, and a feeling both in the, I think in the, well, there was a difference of opinion in the discussion session, but in the business meeting, the people who were there were pretty much agreed that an AGI journal would be a good thing. A major issue, well, let me put it this way, it wasn't thought that finding a publisher or arranging for the journal would be that much of a problem, although it would take effort, certainly. But the major issue might be finding managing editor or managing editors.
We got 4.
Oh, is that right?
That was resolved.
They did get 4. Anyway, a journal is a lot of work, and that's an issue. Then there was a group on how we should organize, and there was a lot of discussion on how to use online organization with a professional version of some social network that would allow us to communicate. There was a strong feeling that this network should help individual researchers with their research projects by letting them communicate with others. And there was also some feeling both in the discussion session and I think in the business meeting that we should continue as best we can to operate within and to take advantage of AAAI and to do the things that we need to do with them. And we'll see whether or not this will lead to a separate organization or not. Did that essentially do it, or did I miss some things?
Sounds right, Stan.
Okay, thank you.
Network, you also mentioned the competition intelligence society.
Yeah,
Say it out loud. Let Vadik say that. I couldn't be in 3 places at once, so I missed some things.
I think AAAI is certainly the organization to go, but also IEEE is very much interested now in similar issues, and Computational Intelligence Society is one of the fastest growing there, and I happen to be involved in that too, and as well as several network organizations, the European one, which I'm currently heading, and the international one, and all of these organizations are very much interested in the same issues, so we should not forget about them, and we can link our social network to this. Yes.
Good. Thank you.
So regarding the stuff Stan was talking about, the only thing I would add is if anyone who didn't come to the business meeting or wasn't in the appropriate section of the business meeting, if anyone's interested in helping with the formation of a possible AGI journal, you should contact Pei Wang. And if anyone's interested in helping with the organization of an AGI-09, which will very likely be in DC, or in the formation of a sort of AGI network to mediate online information sharing, then you should contact me, and we can certainly use all the help we could get with all these things, because we're trying to get our research done, and doing these organizational things in one's spare time can be a big job. So I'm going to now briefly introduce this session on the AGI roadmap. Basically, my goal here is just to give some idea of what the heck we mean by an AGI roadmap and what questions may need to be explored in the thinking about and formulating such a thing. Then I'll turn it over to our panelists, each of whom will give some brief remarks on their thoughts. And some of them have prepared presentations, others will speak off the cuff, and then we'll turn it over to discussion. Certainly, we're not going to formulate an AGI roadmap in this session. If we come out of it with some resolution that formulating an AGI roadmap is a good idea and what that means, that can be a basis for ongoing discussion and maybe a focal point of interaction via this AGI online network we've been discussing, which could be a good medium for the collaborative creation of such a roadmap. So, part of what started me thinking about the notion of an AGI roadmap was a couple other recent documents which I enjoyed reading. One is nanotechnology roadmap, which you find at the website of the Foresight Institute. The other is something called the metaverse roadmap, which has to do with the online virtual worlds. And I'd say that these are different sorts of documents. The nanosystems roadmap is really highly detailed technical document about the development of strong nanotechnology, leading up to molecular assemblers and all the good stuff. The metaverse roadmap is a bit more of a high-level document, and it actually already in some parts is obsolete because virtual worlds technology is advancing so fast in the last couple of years, whereas nanotechnology in the strong sense is not moving ahead as quickly. But what we can see in each of these cases, and in some other cases within computer science, say in the agent systems roadmap, which was published in the computer science journal whose name, Autonomous Agents and Multi-Agent Systems. In each case, the goal is for a bunch of leading researchers in an area to get together, sort of set aside their debates about the various issues and see, well, in the big picture, what do we want to do? What's step A? What's step B? What's step C? Well, what are milestones for the progress of the field as a whole that over a substantial period of time could lead us toward achieving our long-term goals? And as to the value of this kind of document, I mean, one observation I can make is Jerry Paffendorf, who was one of the leaders of the Metaverse Roadmap, recently spoke in Singapore, and the Singaporean government decided to adopt the Metaverse Roadmap as a kind of strategic initiative guiding some of their research expenditure in that area. And I do think, getting back to our discussion about internationalization, there are, particularly in Asia, but not exclusively, there is a sort of tendency to adopt kind of large-scale roadmaps and multi-year plans to guide research funding. So I don't think it's infeasible to think that an AGI roadmap could actually affect decisions involving an expenditure of money. It's not the kind of thing that happens overnight, but I think it can make a big difference. And that comes back to some of the comments that some folks from the funding community made to me yesterday during one of the coffee breaks, is that there's a lot of different ideas being presented here. They're kind of waiting to see what's the consensus, what's the right approach. People listen to us talk, it sounds like there's more approaches than there are people, and that has some truth to it. On the other hand, there's often more commonality than is apparent from the different emphases and different languages that we use to describe what we're doing. So I don't think we should try to squash or hide our differences, because the debate about the differences we have is what will move the field forward. But to kind of lay out what are the commonalities in a directed plan going forward, if we can do it, would be extremely valuable in terms of making what we're doing comprehensible to the world at large. So I'm just going to take a couple more minutes and run through some questions I think are critical to look at when formulating a roadmap in AGI or basically any other field. What are the really hard problems that we face? And we may not agree on this, but that's something that people would like to understand when looking at the field as a whole. What are the approaches that look most promising? And it's all right if we don't all have the same idea about it, but if there are 500 approaches to each of the hard problems, that's different than if there are 3 or 4 main approaches that seem to make sense to pursue. And that gets down into detailed questions that we're not going to be able to discuss here, but that would have to be in a roadmap at the level of the productive nanosystems roadmap. What approaches look best for knowledge representation, learning, reasoning, overall system architecture, language understanding, teaching a system? And that comes down to robotics, virtual worlds, chatbots. You know, in terms of system architecture, can we take the dozen architecture diagrams and say, well, this architecture diagram is agreed to by a lot of people, and then some people want to add this, some people want to subtract this, some people want to add this. And if you can present some kind of overview of that in a way that people can understand, even if it's a 200-page document, that's better than reading 5,000 research papers. Which one of these looks like the worst bottleneck? And then there becomes a strategic question. Do you focus on the bottleneck first, just to be sure you can resolve it, or do you put it off to the end, hoping the neuroscientists explain for us what to do? What other enabling or simultaneously developing technologies do you think are most likely to play a critical role in fostering the path to human level AGI? And this certainly is important. If you're, for example, the government of Singapore and want to figure out how to coordinate your AGI expenditure with expenditure on other things, I mean, do we need a lot more hardware, or is the current hardware trajectory good enough? Either one of those is an important conclusion to put in a roadmap, actually. Do we need FPGAs to evolve neural nets, or can we use commodity processors? Are graphics programming units important? Do we need topological quantum computers to have a prayer of doing anything? Let's hope not. We don't want to fall into the mistake of saying we're going to make a roadmap that will lead to human-level AGI by 2012 when the Mayan calendar ends. So, I mean, the AI field has made a lot of mistakes before in terms of overconfident predictions. On the other hand, if you go to the opposite extreme and say we have no idea when anything can possibly happen, then that's very unappealing to funding sources. So a lot of tact and care is going to have to be put into what are reasonable confidence intervals for achieving various useful and interesting functionalities out of AGI technology. And certainly I don't have the answers to that, but I'm curious what other people's impressions will be. Finally, what's a meaningful series of milestones for AGI development to proceed through in the next period? Where is AGI technology going to go in the next few decades? And finally, something that came to my mind when talking to not many people about this is the AGI field just too fragmented to have a unified roadmap at all? Do we all disagree too badly? And if that is the case, can we kind of cluster ourselves into 2 or 3 groups and say, well, here's the integrative AGI roadmap, here's the neural net AGI roadmap, here's the Bayesian AGI roadmap, and even having 3 or 4 roadmaps which are each coherent and sensible is still a lot better than having a fragmentation where it's every man for himself. So there's certainly a lot more questions than answers here, but I do think that collectively going through this exercise as a community can help us both to interrelate with each other better in collaborating on our research and to present ourselves in a more coherent and convincing way to the outside world. Let's start with Stan Franklin.
Wow.
You look like you had a really profound thought in your mind.
My profound thought was that I find all this really intimidating. That was the profound thought. I guess that thing's working. Whew. I guess I really don't have a lot to say about that, so let me see if I can say it quickly. Where should we go? First thing, let me say that I think the idea of a roadmap, as Ben has laid it out, is not only an excellent idea, but it's probably vital that we do it. And I certainly don't want to come to the conclusion that we're too divided to have one. Now, it may turn out that way when we try to make it, but I think we should assume that we really can come to some consensus that also acknowledges our disagreements, because, as Ben pointed out, the disagreements will move us forward. Okay, where to start? I think the place to start is with system architecture, and I like the way that Ben has laid it out. I think we really need to agree on a basic architecture as much as we can, with allowances for people saying, hey, I think this is wrong. And in this document, we need to do all of that as best we can. I'll push for my view of this thing, that I think this architecture should be in terms of cognitive cycles, action perception cycles, as the neuroscientists call it. That the idea is that an AGI agent would have to go through sensing, deciding what to do, and acting, and doing this over and over again. And all of the higher level cognition should be built out of these cycles. Now, that's my personal view, and that's what I'm pushing for. Okay, how to achieve this thing? I think we need very much a special purpose workshop on AGI architectures. There was an attempt to put one together. It failed for one reason or another. I think we need to do it again. I think we need to find funding for it, and I think it's the kind of thing that we may be able to get funding from some of the agencies for. And I think it needs to be something like 3 days at least. And I think it needs to be in some place that's very easy to get to. Yeah. All right. Finally, I want to push for one more thing that comes right out of my own research and I realize I may get a lot of disagreement from this. There's a real question of how to sell AGI. It strikes me that there shouldn't be. I mean, it's such an interesting question. It's one of the most interesting questions. Why should you have to sell it at all? But not everybody agrees with me. Right? And there are a lot of ways to sell it, and people have talked about it, and I don't, the one I'm about to push at you, I don't want to put forth as the only way by any means, but just one addition to the other ways of selling it. What I'm really interested in is how minds work. Human minds, artificial minds, animal minds. I view this, what you need for that is some high-level theory. I wish I'd made a diagram, a high-level theory. You can't do it in terms of neuroscience. Neuroscience is too low level. Between that high-level theory and neuroscience, you need nonlinear dynamics. Nodes up here, concepts up here correspond to attractor basements, which correspond to trajectories on cellular assemblies. All right, so I've got this high-level abstract theory, like myelida or lots of other theories. SOAR, for example. Yeah? You've got to have a high-level theory of this kind. What do the high-level theories depend on? They depend upon behavioral research in cognitive science and real empirical research down in cognitive neuroscience. So you've got to have that. What else does it depend upon, this high-level theory? It depends upon computational implementation, which tells you whether or not the theory is coherent, whether it has contradictions, and whether or not you've got the parameters right. You know, can you match the empirical stuff? This high-level, this implementation of the high-level theory, in my view, is AGI. And we can sell AGI, along with other ways of selling it, as very important, as critical to the whole issue of how minds work. Now, I think AGI shouldn't have to be sold on that basis or any other basis. You know, I think it's vastly interesting in itself. But a lot of people who are not interested in AGI are interested in how minds work, and I think you can sell it to those people using this approach. Done. Sorry to be so long.
Can you turn on to my screen? Well, I have one proposal that we appoint the editors of wiki pages that will be all the pages trying to define the roadmap, right? And then people can write there, and the editors will put that in some coherent order, and in this way we can try to develop things. I want to say that there are several other roadmaps that I know of that are kind of, well, useful for us. First, Marvin Minsky and Pashing have written a paper in 2002 on 10 years roadmap to machine with common sense. If you haven't read it, I have it with me. The other two is the European Union Robotics Group, which has a research roadmap that has been written in 2004. And then there is a Neuro-IT roadmap. Neuro-IT is basically a connection of neural technologies with information processing technologies. That has been published in 2006, and there is an earlier version that was in 2004. So there are several good examples of a roadmap, and especially Neuro-IT is very relevant to what we try to do, as well as Minsky's roadmap. Now, we have to define a series of challenges. I would really love if we had a platform on which we could, test different approaches, like LiDAR or solar approaches, etc., so that people will be able to just add to this somehow. My idea in Singapore was that basically we should integrate lots of things that people are doing, give them a platform, and then announce, okay, we need this functionality, we have it, but it's not ideal, can you really improve that? And lots of people could work that and just try to extend it, but we need a platform in which we can, using which we can experiment and add things. It would be really wonderful if we had a community where people can add your codelets, for example, so that they will extend some functionality, or add little pieces. I mean, there are several architectures now where people talk about really having specialist codelets or other little pieces which could extend functionality. So then we could have a larger community doing that. That I would really be happy to. But also, to get some visibility, maybe, we need to define some challenges and try to organize competitions. As I mentioned yesterday, the only time AI became really famous in the news and media was when Blue one with Kasparov, right?
Yeah.
And so perhaps if we can find a challenge that is as well interesting, but then if the computer wins, the computer will not be blamed that it's just fast. That would really bring lots of interest into it. My own take on this is in the 20 question game, as I mentioned, because that doesn't require fast computing, it requires fast knowledge to formulate proper questions. And nobody can say that a fast computer can, formulate a better question and guess what you have in mind faster. That is quite impressive. There is only one implementation of this, which is kind of a template matching, so they're cheating. We have another implementation, and we have also now an editor, because you have to collect lots of knowledge for this. And now, again, we can talk about language understanding and other things, but it's just too complex for me. I think we have to do it incrementally, and this is starting from the simplest game, which just needs an object description, which needs information, what kind of properties can be applied to objects, and then you can play lots of things, like you can try to guess what people have in mind when they write you keywords, and it's very ambiguous, and you get lots of pages, but the system can ask you, well, would you, think about this or that, and in a few questions you can get really precise information what people have in their mind, and then look precisely what they need. So that's the first step, the simplest games, like 20 question game, and maybe then yes-no game in which you try to understand the situation. You are just allowed to ask questions and then get an answer yes-no, and you try to guess what is it all about, right? That's a very difficult thing. Things like logical entailment, there have been recently quite a few competitions on that, are again something that's very important, and if we can do some progress in here, that can be quite popular. And well, finally, to get this knowledge somehow into the system, we're going to announce soon a collaborative project on concept description. Basically, we have a WordNet-like editor, which is a graphical editor. We're going to bootstrap on all kinds of knowledge we can find automatically in the network. And the idea is to provide something like WordNet, but on sub-symbolic level. So everybody could then use the concepts, which will be sub-symbolic. And so they'll have lots of associations, and you could use it in your chatbot, for example, that will finally understand what the concepts that appear in the discussion are about. And for that, we're going to have lots of knowledge which is not verified, and provide kind of a visual editor where you could correct that. And I don't think you can fully do it in an automatic way, so we have to do it step by step. I have lots of other ideas, but I better pass them back.
Great, thanks. So I agree with Ben that a roadmap is very important, but I think a roadmap is not just what direction to go in, but what the endpoint is. And so I actually think we need two endpoints, because this technology doesn't sit in a vacuum. Once the first successful AGI is created, it's going to dramatically change the nature of humanity. It's going to change the structure of society. The first group that creates it is going to have awesome power that can be used for good or for bad. And so I think we need to look beyond the creation of the first AGI to the society we want to see, say, 10 or 100 years beyond that, and have a backwards going roadmap that looks at, once the first AGI is created, how do we use that and guide that to create a society that's positive for humanity. And so, and I also believe that doing that effectively will change and will affect what architecture we get. I'm going to put in a little plug for this afternoon session. I'm going to argue that pretty much no matter what architecture you start with, any AGI is going to want to modify itself, and in doing that modification, it's going to want to eliminate irrationalities, and it will basically converge on a rational economic agent, as described by von Neumann in the 1940s. And so the ultimate system, after iterated self-improvement, will basically be described by a utility function that describes what these agents are trying to accomplish, and by a Bayesian updated belief function that describes how it accomplishes that. I view the many wonderful attempts to build AGIs today as approximations to that ultimate kind of a system. And I think that the roadmap, rightfully so, should investigate. We're in an amazing time where we're just understanding the human genome, we're just understanding neuroscience at a level of detail that's unprecedented. The one area that hasn't really influenced AGI systems so far is neural development, in which there's also a huge amount of, maybe Hugo's work plays on that, but I think There's a lot of understanding of how the human brain develops from an extremely small portion of the genome that describes the entire structure of the brain. You know, and so there's huge leverage, I believe, in that pathway. Modeling cognitive behavior clearly is you know, an excellent pathway. And then taking the rational approach. My own approach is to use a combination of theorem proving and Bayesian learning to build rational systems. The advantage of starting with a rational system is that we can directly encode the utility function, what we're trying to accomplish with these systems. Whereas with some of the other systems, the behavior, the ultimate goals emerge out of their long-term process of learning. So I think the roadmap is important, it's good, but we also need a roadmap saying what the consequences of these systems will be, and that the two should sort of merge in the middle.
So it's very tempting to just respond to the previous speaker, but I think the most important thing, so fine, I'm on board with the roadmap, but I think the most important thing to make progress in the field, that's what I think about, is how does the field move forward? And the most important thing for that is for us to start having shared tasks that we work on, where we also have agreed upon metrics for measuring performance. Very few of the presentations here ended up with showing you results that said, when I added, I didn't do this, but when I added this feature, or when I have this system that's different than somebody else, here's the improvement in behavior I got as a step towards general AI. So I think we need to have a workshop, and it's not something, this is not something you do in one day or one workshop, but I think we need to have a workshop where we get together and say, what's a roadmap in terms of a set of tasks that these systems could work on, and going from maybe easy to much more difficult. And here's my inspiration for how you come up with these. You've heard my talk, maybe you've read my papers, and a lot of people, I think, have visceral reactions to SOAR in terms of that can't be the way humans work. That's fine, but why isn't it? And give me an example. What's a task that your system can do that my system can't? And then let's put it out there, and then let me see if I can do it, and let's show that you can do it. I think that to get credibility in the funding arena and also in the scientific community, we're going to have to go down this path, because if we come up with a roadmap in terms of here's where we're going in terms of more and more difficult tasks, and I wouldn't actually say we're going to achieve them in this year or that year, then funding agencies feel a lot better about providing you money, because they know what you're going to do. And so, and personally, if you ask, so what kind of tasks should we be concentrating on? I think number one, we should have tasks where we banish the homunculus. We have to have tasks where there's end-to-end behavior by the system, and the more and more we can eliminate pre-programming, where the system is learning from interaction with the environment or interaction with other entities in the environment, such as Ben showed with training the little dog. But it has to be much more complicated than that. So one of the key capabilities of a general intelligence system has to be what I call taskability. You can take instruction from an outside source and do new tasks that that the person who programmed the system never knew before. And it's not necessary that there's one global goal for the system. Well, maybe we could argue about that, but that the system can be directed to new tasks. Those are going to be modulated by its own drives and things like that. But I think that's really important, is being able to do new tasks. And I think that it's important that it be situated in an environment. So one of the things that's come up a few times is using using virtual environments. And I think that might be a good one of the paths through a set of tasks. So I don't think you have one task or just one set of tasks. You have batteries of tasks that go on time. And so maybe if we could have, as a community, jump onto one of the virtual environments and have common interfaces to it, and then cast tasks in them that involve interactions with the environment. So I shouldn't say this, but there's a lot of examples where people do things in virtual environments where it really has very little to do with the fact that you're in the virtual environment. Some of the theory of mind examples, you could do that in a text-based system just as well as being in a virtual environment. Let's come up with tasks. Sure, we want to have a system that does theory of mind, and that should be part of it. but I think the emphasis should be on tasks that really take advantage of the fact that we're in a dynamic environment that has lots of other entities in it, and so on. So that was my first little step. I don't have a lot more to say, but I also, one thing I vehemently disagree with is the idea that we're going to be able to have an open source system. That we have a lot of people just contribute it. You think, oh yeah, that's pretty close, I'm going to make a small change to it. My 25 years of experience is that you got to have a somewhat singular vision of a few people working very closely together in order to push these architectures. In order to get efficiency, which I think is also critical, you've got to have people who are willing to put code together and it just doesn't work to add new code. If you look at the successes in the open source community, they were not research programs. They were systems that were doing it for the third or fourth time. Firefox was not the first system to do that. It only was because people understood what the problems were and they could go off and do it. And so then open source works really well. The other thing is, I am going to disagree with the previous speaker that, well, there was an implicitness in that someday we're going to achieve general intelligence. It's going to be, well, people might make press releases that they've achieved it, but that doesn't mean they have. It's going to be a gradual thing, and it's not going to be suddenly you turn on your Toyota robot and it's alive and you feel like, oh yeah, this is a general intelligence system. It's going to go and talk to me. This is going to be very my prediction is going to be very gradual. And what's going to happen is we're going to see applications of this technology throughout the commercial sphere where you won't be able to identify that, yeah, that is a general AI. It's going to have a lot of the capabilities. It's going to have natural language. It's going to do some common sense reasoning. And then it's going to be, because there's, at least, except maybe in Japan, there's an economic motivation to create a human-like general AI. I don't see that, at least in the United States, for many, many years. And so I don't see that people are going to do that. They're going to have these other applications. And someday we're going to sit back at AGI 2050 or whatever, and we'll just say, oh, I guess we've achieved it. You know, that we're going to say, look at all the evidence from these 3 systems. If we look at those 3 or 6 systems, yeah, we have general intelligence. So that's my view of where this future is. And I don't think we want to say that there's going to be this singularity that suddenly we've achieved it.
I agree with a lot of what the previous speakers have said, so I'm going to focus on where I disagree to be interesting. So first of all, Stan and I definitely agree that AGI is great and doesn't need to be sold. I think what needs to be sold and what the roadmap should try and focus us on is whether or not we can deliver AGI, and I think that's why there's a lack of funding and a lack of interest. Nobody thinks we can do anything interesting. And I think in order to show that we can do something interesting, there should be a universal roadmap which consolidates and contextualizes the goals of the AGI field. I think, unfortunately, we're too fragmented for that roadmap to work backwards into particular milestones. I think in order to have milestones, you need to choose a particular paradigm, such as integrative AI or large-scale multimodal Bayesian data mining. And I think once you've chosen a paradigm, then it's great for the people that are working that paradigm to get together and compose a roadmap with challenge problems and explain how that paradigm will lead to the goals of the AGI field. I think it's a point that's been made many times, but it bears repeating to Ludwig in particular, that benchmark problems taken outside of a particular paradigm are much less helpful and give a much clearer picture of how a system actually performs and how it's progressing than benchmarks that are carefully chosen within a paradigm. For example, Stephen Reed has an approach to AGI based on understanding of language and formulating knowledge in a logical format. And it's very difficult for me to see how you could come up with a set of milestones that would be meaningful meaningful to his approach and also meaningful to an approach like Ben's based on embodied agents. I think it's great to have, I think that the milestones for embodied agents should be based on the particulars of how you expect the embodied agent to become an AGI, and I think the milestones for textual and logical AI should be based on that same rationale, but they should probably be totally different. And so that brings me back to John's point that we really need higher standards and for AGI research, and we need to decide what makes great AGI research and how is that different from what makes great narrow AI research. And having a roadmap to invoke, having particular milestones, I think is one way to justify that AGI research that particular papers and results in AGI build within a paradigm and they demonstrate results or prove theorems just like narrow AI papers do. I would also like to note, however, that there's the sort of separate task of synthesis in AGI and building these paradigms, which is extremely difficult but does not involve producing experimental results or proving theorems, and I think possibly there could be a separate track at the next AGI research, at AGI conference to allow for this distinction, and that papers that give results and prove theorems should be accepted.
Wow, that's really radical.
Okay, I also have a few slides. Similarly, I have a lot of agreement with previous panelists and also a lot of disagreement. But instead of talking about those, I think I will make another change. I will just talk about the roadmap I have been following in my research. So the issue or the difficulty about AGI roadmap is it's tricky. We know intelligence is very complicated, no matter how we understand it. So that it's pretty natural that we will want to do the familiar thing for computer scientists, that is divide and conquer. But on the other hand, what makes intelligence complicated is especially because all the parts are closely tangled together. So very often you're going to cut it wrong. That's actually a major problem in traditional AI. So what I have tried is what I call a unified approach, where I start with so-called a unified core, with what I believe the fundamental of whatever AGI system you build need to have. And also I try to make it as simple and as possible, some kind of minimum approach. The core by itself cannot really do much in terms of practical application, but I want it to be very general, flexible, adaptable, and scalable. Okay. And after that is finished, I think we can build a lot of stuff on it kind of in parallel. So here, the major theoretical assumption is whatever I put in the core is what I believe have to be done first. It doesn't depend on the other thing in the secondary storage stage. But on the other hand, I believe whatever at least the secondary have to be based on the core. So my own project, NARS, is actually an attempt to build such an intelligent core system. Okay. What I did is design a unified representation, a unified processing mechanism, and a unified memory and control mechanism. Okay. Most of the stuff already finished, and what I'm working on now is the last major piece. That's listening and learning on procedural knowledge. Okay. Clearly here is not the place to talk about the technical detail. I just try to show a big picture. And all the details, well, there are a lot of reference on my website, papers and books, and also the project now is open source, so you can check this out. That's it.
Can I have a response?
Yeah.
If I may start off. I was very much taken with what you said, John, and very much in agreement. And I'd like to specify a little bit about where I think we should start, so to speak, in this thing. It seems to me that any AGI that we create is going to have to, in spite of the theorem provers and this kind of thing, is going to have to interact with an environment of some kind or another before it can be accepted as an AGI. But let me not argue that point. I'm giving it as an assumption at the moment. An AGI then is going to either have to react to its environment in the real world or an environment in some virtual world. In order to do that, it's going to have to sense the environment one way or another. We're going to have to choose a sense or senses for this AGI agent, for the approximations to it, as people are pointing out, because you're not going to get there all at once, as John told us. He's quite right. Which senses shall we choose? Well, I think we need to choose visual senses. And the reason I think that rather than other things is that we humans are visual animals, and an agent that's more like us in that regard is going to be a lot easier to sell all the way along the line. So I think that we need to have a real push for visual sensing in an AGI agent and its ability to make sense of its world using a visual sense. One last point on this. I also think that any reasonable AGI agent is going to have to have all the way through a common representation that it can deal with for cognitive things. And that this representation should not be amodal, but should be sensory representations in the terms of Barcelow's perceptual symbol systems. And I think that we should start with that, with vision. And that's what I want to put out.
That's interesting. I'm going to briefly respond to that. And
okay.
Continuing in the tradition of the panel, I'll focus on my disagreement. So I of course agree that virtual worlds of some sort is one very good way to structure a roadmap toward AGI, and I think I can contribute about to Eskana Sibley, who was here yesterday. I'm not sure he's here now, but about what virtual world technology is most appropriate. There's an open source virtual world platform, OpenSim, I think is promising. And one of the things that's going to be interesting in that regard is just getting collective feedback on what we want out of a virtual world to really be appropriate for AGI. The thing that I don't necessarily agree on is that vision is the most important sense. I tend to think it's the second most important sense, and unfortunately the most important one is hardly supported at all in current virtual worlds, which is the sense of touch. And I feel like you have an embodied agent that can't feel itself there and can't kind of feel its own body as distinct from the rest of the world. That is most likely problematic in terms of the AI system developing a sense of self in the same way that human children do, even vaguely. So I do think vision is really important. I mean, novamente, we're dealing with only vision in the virtual world now. We're not doing smell or touch or sound or anything. But it's, I guess the way virtual world's right now, you don't really have a sense of touch in any good sense. And I think that that's something that could be redressed within the OpenSim community. And if we made an AGI roadmap saying, well, these are our requirements for vision, these are our requirements for haptics, these are our requirements for sound, in order that AGI can really use virtual worlds, I think that could push, for example, the OpenSim development community to actually do those things in the virtual world. And that's another advantage of having a roadmap, because if I, as a researcher, say, these are my requirements for you, I'll be like, well, Okay, great. So the AGI community as a whole wants these requirements that OpenSim can be used for AGI. You have a little more leverage, and that has to do with vision or touch or any sense that you want to focus on.
I agree with all you say, by the way. No quarrel with it.
Yeah, let me just say, we're talking about things like vision, which are very difficult. So maybe we could make a list of things that humans are better than artificial systems, and then say, okay, can we try to solve some of these things with general architectures, not narrow AI or specialized AI, and can we just run them in the level of difficulty that we think they have? And that will not be unique, but to some degree we can agree that there are simpler things and more complex things. And some of the things that Ben has mentioned, I would really love to see them done, but I'm afraid they're fairly difficult, and it will take us quite a while to do it. So I mean, one thing on the roadmap or on the wiki pages, etc., just to try to come up with the tasks. Humans are better than, I mean, you remember maybe the cartoons, I don't remember who done that, but it's in Kurzweil book, right? With the notes, only humans can do this, only humans can do this, and some of those are running down on the ground. And if we could have something like that and say, okay, there are simple things that we may do in a few years' time, and more complex things, that would be a great thing. Then, well,
I tend to think that's exactly the wrong approach, actually, which is nice. I feel like there's plenty of things only humans can do, and if you pick them off one by one, you're likely to be taking a narrow AI approach of coming up with funky ways to do particular things that only humans can do. And I happen not to think that's going to be the way to get to AGI.
But that's why I said that not just with the narrow AI, but something that we can do with architecture like SOAR, extended SOAR, or your architecture, for example, right? So that we can compete with the architectures that do not just one thing, but many of these things.
Yeah, but I think we need to look at what our goals are, and not just what the hard things or the easy things for humans are to do. We can analyze our systems and say, we know these are hard things to do in computational systems, and so I think that should be the basis of the roadmap, as opposed to just looking at humans. I mean, if you want to ask what's one of the hardest things for us to do, that humans can do better, is vision. Yeah. And so going into a virtual world lets us punt on that for now. And maybe that's going to screw us in the long term, because maybe vision is so critical to what we do.
But that's interesting, because it doesn't completely let you punt on
it. Doesn't
doing object identification in the virtual world is a real problem. It's just not nearly as hard as doing it in the physical world.
That's right.
But these are certainly subtle points that we'll bang up against when you try to make the details of a roadmap.
But why should we concentrate on things that may easily fail and just neglect things that can be done and can still prove that somehow artificial general intelligence works in cases which still are in the domain of human competence? I mean, I wouldn't neglect that. I quite agree, there are other problems one has to concentrate on, but if we just concentrate only on hard problems, we're going to fail. Or for long years to come, we're not going to show anything that the public will say, oh, that's interesting. They still try to solve the hard problems, right?
Well, those are just two approaches. You can try to focus on what's the hardest problem, because otherwise if you just play with easier problems, you may be going in completely the wrong direction. And after 10 years, you realize, oh, we never solved this basic issue at the core. So my orientation is kind of exactly the opposite. To figure out what's the absolute hardest problem and focus on that.
Okay. I wonder if it's possible to step away from the problem itself and first define a roadmap for AGI as a field. And we've got the need to define problems, we've got the need to define measurements, we've got the need to create theory and methods and architectures and look at ethics and scope of that problem. First create a roadmap for AGI as a field. Each group can create a roadmap for AGI, the problem, and then we can use the roadmap for AGI as a field as a template to report our progress. It's a way to report our progress, but the actual milestones, the individual techniques really come down to us as research groups, and it really serves as a template for a whole of AGI roadmaps.
I wanted to say, I think a good task is one that's not too simple or too hard. I mean, if it's too simple, yeah, that's right. If it's too simple, then it doesn't stretch you at all. If it's too hard, then you don't make any progress on it. And I agree that vision is a great domain, I also agree, somebody said that we should have a complete closed perception action loop. One project that one of my students did was we had an ordinary robot arm and a camera looking at the arm. And the task was for the system to learn the kinematics of the arm and the imaging geometry of the camera. That was pretty easy to do, but that setup very naturally gets to harder and harder things. You can have, visual things that are very difficult to recognize, things that are easy to recognize, and it's sort of a limited world which you can kind of gradually get very, very complex. I think some of the virtual worlds have that advantage also, though the virtual worlds may miss, properties of liquids and complex.
I think that perhaps one of the elephants in the living room here is that there's not really deep consensus and theoretical unity among us about how an artificial general intelligence ought to work, or even how to define intelligence. Shane Mudd has this wonderful collection of 71 definitions of intelligence. And I suggest, therefore, that creating tasks that we all agree would be impressive if we solved them. We're likely to find more unity among ourselves in saying, if we could do this, that would be cool, than saying, well, we're going to do this. I do think that, if all the Bayesians go into a room, or everyone who agrees that Barcelona's perceptual symbol systems is just an absolutely fantastic idea, go into a room, they will be able to find some degree of unity. So I think that the cluster roadmap suggestion may have been substantially more realistic. But if you ask what can you take out of the clusters, I think that in terms of creating specific tasks and saying, we're not going to tell you how to do these tasks, but if you can have one system that does this task, and this task, they shouldn't be like very, precisely specified tasks, because then you just match them. It's sort of like, we'll generate this kind of game that you have to learn how to play it on the fly. We'll put you in this kind of virtual environment, you have to solve some kind of problem on the fly, and you give us one system that does all 4 of these tasks, and you're clearly doing some kind of cross-domain general reasoning, even though we're not going to tell you exactly how to do it.
There's too many ideas out there that have not been proven or proven wrong. They've not been proven correct. And I think it's really dangerous to put your star to a system that hasn't completely implemented yet. They might have a lot of good ideas in ours, but there's no evidence that it can turn over yet and it can scale to hard problems. I think it's very premature. I think we need to allow a lot of different systems to grow, and the integration point is the common tasks. So that's where we get people to talk to each other, because, oh, how did you solve that problem? Oh, well, I used mumble quantum neural systems. Oh, well, maybe that's what I should have used, because it really stumped me. And that's where you're going to get the cross-communication, is when people are working on the same problems. It really brings a lot of focus, a clarity of mind about where your strengths and weaknesses are.
Yeah, I agree with that. I think it's having common problems is helpful, and then if one system excels on the common problems, that's going to attract more people to work with. You don't want to replicate what the Japanese did with the sort of 5th generation computing product. Prolog is the answer. Everyone, let's
solvable problems.
It's not generally problems.
that pace.
Yeah, I just want to say that I will go back to my talk in day 1. That's exactly the problem I try to address in that day. I have to admit that I'm a little bit optimistic about the common roadmap, just because of what I believe is we're not really after exactly the same goal. We're after some very similar goals. Because of that, we take a different approach. So to me, in the near future, the best thing we can get is a small number of relatively close to each other kind of small group roadmap. If we can end up with, say, 10 of them in this room, that would be great. Not 110. Okay, that would be already great. It's way too early to try to get something. And also, it's dangerous.
Yep.
We don't really know that much.
Yep.
It has to do with the definition of what a roadmap is, really. I think, and we'll just have to explore that if we try to develop it. Because I agree, I wouldn't want to make a roadmap that would embody like a choice between the NARS inference rules and the PLN inference rules versus description logic or something. And I don't think that a roadmap is supposed to specify things at that level of detail. It's going to have to be a bit broader than that.
Well, even the milestones, it depends on what's your goal. Why we have different idea of, for example, whether Deep Blue is a success of AI or not. We have different idea because we evaluate inheritance differently. Some people just say that inheritance means solve hard problems. Chess is hard. Okay, Deep Blue can solve it, so it's inheritance. But for some other people, for example, for me, well, almost not. Okay, because I evaluate inheritance according to something else. So I will have my milestone.
I guess not much has happened in AI for the last 50 years.
Well, if it's going to be that way, then there's 10 different roadmaps based on 10 different paradigms. I'm afraid that in that case, the road mapping exercise is going to be close to useless and is not really going to help us in terms of outreach to the world at large or to funding sources. So I hope we can find the right level of abstraction to make a roadmap that is more inclusive than that.
Yeah, but in the end, what counts is what you're able to do. So if you have shared tasks and realistic tasks, you may do different ones than John may do or we may do. That's fine. But at least we have tasks, and they should be tasks that well, we're not able to do now. And if we are able to do them with general architecture, that's wonderful.
That's exactly, to me, the problem. What you define as a task for AGI may be different from what I see as a task for AGI.
Well, we better find that out pretty soon.
Okay.
So I would also make the claim that this is something you can get money from NSF like that to do a workshop on. Because this is exactly what they strive for, is to get people together and put aside their differences, but to come together on something. So I would think it would be pretty easy to go to SIZE and say, we want to have a workshop, a 2 or 3 day workshop where all we're working on is coming up with these tasks, and then there may be a follow-up workshop 4 months later, 6 months later. I think that would be a pretty simple thing to do and very valuable for this field. I think you will get instant credibility if we have that sort of document that we can show to people.
So we can look at kind of the formulation of a good set of tasks as sort of step one toward potentially formulating a roadmap, and also as being valuable on its own.
And it doesn't replace doing the roadmap. I think the roadmap has its own value. The only one thing I would be very cautious about putting dates on milestones. Yeah. And AI has done that many times, and nobody's ever done it right. So, I mean, Kurzweil, luckily he picked it far enough in advance that he can sort of sell a lot of books for a couple decades before it runs up against it. But I think the only date you're safe at is saying, about when you're going to be about 120. That's a good date to pick.
But he wants to be immortal, so he may be 120.
You're right. I'm sorry. He has a different view of the world. Yeah.
So I've got a proposal for a task, which is, the RoboCup is great, but it requires expensive robots. Not everybody wants to do robots. How about virtual competitions like that? Sort of like virtual. Is there virtual soccer? Maybe pick one of those that has sufficient complexity that different systems could actually compete with one.
It's not general. I mean, so you do virtual soccer, and the guys who are going to win are going to be the people who study soccer, and that they create specific algorithms for that. And the whole point of this is I want to be able to take 6 of them. So having soccer as one of them is great, but I'm going to be judged not on how well I do soccer alone, but how well I do these other tasks as well. So sure, maybe soccer is something, but there's no one task here. The whole point is generality.
It's a game of the ball, we're not going to tell you what it is.
Yeah.
Okay, I mean, if we can have something like general intelligence quotient, right? That would be something, okay, I get this much points in soccer, I get this much points. You're improving, I sum my points, and this is how intelligent my system is.
We're going to prove theorems about soccer and unify them.
You should go to the speaker who's got the light.
Yeah, right. Something I like to point out, something to keep in mind is, what is the average human life? And it's not Leonardo da Vinci. It's Homer Simpson. It's closer. Rational economic models
that the goal?
So that's what we're going to use to run our nuclear power plants?
Yeah. Click your button. Yeah.
Okay. I like very much the words. The roadmap is vital, and I wrote it with in the uppercase, and I realized that this is my name. That's I'm Vitaly. So I should add 3 points to that. First is probably I have a problem which will be solved very fast, and I already named this problem. It's IQ test solver.
IQ test solver.
Yeah, it can be just solved very well. Yeah, and then there are also 2 ways of moving forward. First is just take a complex problem like chess game and solve it one by one, and another is just to use a complex problem. And there are 2 examples of complex problems which are named in recent Ben's paper, and I came to both of them independently. And the first one is digital mirror. And it's very easy to start with, and it finally will lead us to AGI. And the second problem also, I start to think about that, and it probably, there is a real world which exists in which it's really to build a system which will work, and this is artificial scientist. So it's probably more or less easy to do. I started to draw squares, and they were multiplying. So that's my offers for a roadmap.
One of the things I love about this gathering is that there are people more optimistic about AGI than I am, which is extremely rare for me to find.
Artificial mathematicians maybe.
Oh yeah. It's easier. Yeah.
So I have to disagree with the proposal to set a set of common tasks for different AGI researchers to try to solve. I think that's the wrong set of incentives to give people, and I think it's much more important to try and agree on common research standards, and there are a lot of great papers at AAAI, and I think we need to distinguish what makes a great general AI paper and measure things such as being able to do transfer learning, being able to apply the same techniques across multiple domains, being able to solve problems end to end, and I think that's what we should focus on, and not constrain researchers who may have totally different approaches to focus on the same problems.
I'm more confident that common environments and common things to interact with, common tasks generally conceived are useful than I am that it's going to be possible to come up with a great quantitative metric for comparing systems, actually. I can see if you make a virtual world and have physical objects for systems to interact with, and humans can interact with them, there's linguistic communication. I think that qualitatively comparing different systems as they play soccer or search for objects or try to find information by quizzing people, I think that's going to be incredibly valuable. I do think that saying, here's the score, your goal is to maximize the score, can have both good and bad effects, because you can wind up with people just trying to optimize the score on that task, which really doesn't become all that interesting. You wind up with something like, take the Hutter Prize, which is a nice idea. How much can you compress Wikipedia? Now, to do that really, really well, you obviously need an AGI system, and a human-level AGI coupled with a Lempel-Ziv compressor or something could do that better than anything that exists now. On the other hand, if your goal is to beat everyone else on the Hutter Prize task, you're better off not to go off and build a human-level AGI. You're better off just to make smarter and smarter probabilistic compression algorithms. And so that's kind of the problem with saying a quantitative task, is you wind up putting your resources into beating the next guy by 10% on the task, which is rarely going to be by a general AI architecture. So I'm not sure how you balance that, because having a common environment, common, if everyone's system is trying to do sort of the same kind of stuff, that's really valuable. Otherwise, you just can't compare the different systems in any sensible way. So there's something valuable at the core of it.
Right. I think you said it well. I basically, I would say perhaps within a given paradigm, within a given approach such as integrative embodied AI, I think you can come up with tasks, and I think they'll give you a much better comparison of systems within that paradigm. But since this is a universal AGI conference, I don't think that there are really tasks that we can come up with that all AGI approaches should strive for.
Well, there's not that many different. I think that the word paradigm is slippery, right? So there's the conceptual approaches, and then there's sort of what is the interface between the AGI and then the external universe. So I think anyone who's doing embodied AGI, they may have different paradigms of what they're doing. But if we look at, say, robotics, look at virtual embodiment, you look at text-based interaction, say chat, look at, say, theorem proving. There are 4 different things. I can say for each of these 4 approaches, you could make a series of milestones, you can make shared environments, you can even make tasks, and whether you want to quantitate performance on the tasks and pay too much attention to that is another question. But that's 4 things. I'm not sure how many others there are, actually, but I would distinguish the kind of modality of interaction from the underlying conceptual paradigm, which may vary wildly.
That sounds good. I'd say probably under 10, but more than 3.
More than 3 different modalities?
Pardon?
Go ahead.
More than 3, okay.
Well, what are the others besides the 4?
That's you, actually. He behind you.
I have 2 separate comments to make. One actually kind of continues the discussion we were just having. I think that regardless whether you're trying to compare performance specifically, there is definitely, of course, a point to comparing AGI systems on similar tasks. But you have to be careful about how you choose them and not necessarily compare them to tasks that humans do, or not all the types of tasks humans do. And one thing that jumps out at me there is that it seems that AGI naturally does well and can often improve on human performance at tasks that we consider very internal to the mind. Take, for instance, short-term memory. Very simple problem in AGI, where it's a very complicated thing for a neuroscientist to figure out how it works. Or let's just say the task is list your entire memory content. I don't think any of us can do that. It's simple for AGI.
No, that's not true. It depends on the design of the AGI.
Yeah, for an attractive neural net, it could be difficult.
It could be very difficult.
But you can easily design an AGI that can do that. That is not a difficult task to solve.
Then it's not an AGI that is possibly not going to do well in other areas.
Maybe, but it is not a difficult task. It's not one of those where if you can show it can do this, oh look, it can list its memory, that everyone's going to say, wow, this AGI is great. So, you know, if you're choosing your task, that's something to watch out for. Whereas the external, the things that are more external to us, like motor, sensor, that's an area where what we see humans doing and how in neuroscience, when you look at it, seems to have to deal with a lot of the same kinds of problems or similar problems as what you do when you're dealing with them in AGI. So you have to also solve a lot of the same difficulties. At least to me, it seems that way. And my second...
Can I respond to this one before you go to your second one? It seems to me that an eventual AGI, a century from now, may look very different from human cognitive architecture or from how humans do, in the same way that airplanes look different from birds. But I do think that our best approach in trying to build the first one is to copy them after humans. Because this is something we know works, and then we're going to find out what's necessary to keep and what we can give up and improve upon. But I think we ought to start with copying them after humans.
So would you do that copying as well for these systems that are more, you know, like short-term memory?
I think that it's too soon to start trying to improve on it. Let's see if we can get it first, and then improve. But go ahead to your second point. We're entitled to disagree.
Because you were discussing how many different roadmaps there were going to be, and I understand that it's basically impossible to force researchers to go along one particular path. That just doesn't work. It's like herding cats. It's not going to work. So, but what you can certainly use, was also mentioned earlier, is to have at least a code share, someplace where you can find other things like the Neuro IT is doing for neuroscience, because in computational neuroscience, it's unbelievable how many years have gone by where there hasn't been anything like that. Now it's sprouting up all over the place. NeuroIT is just one group that's trying to do that. Everyone's trying to do it now. But definitely AGI should do that as well.
Do what? I'm sorry, I missed that.
Have a code share, a place where everyone can see what everyone else is doing, basically, and reuse.
Oh, co-share.
Code or code share. Say so.
Code share.
Code share.
Sharing.
Yeah. Yeah, I thought it was co-share.
Code share.
Sharing of software code.
Yeah.
A few years ago, I mean, for one, this whole thing about tasks, I think, is a good discussion. There are conferences that worry about this, like the Conference on Developmental Learning. A few years ago, Nancy Alvarado and I had a paper there that was called Beyond the Turing Test Performance Metrics for Evaluating Computer Simulation of Mind. And it was based on looking at the tests that are developed by the psychology community and the cognitive science community who aren't interested in engineering. And part of the problem challenge we have when we set tasks is we're so much engineers that we're thinking about what's easy, what's hard, what can we build, what can't. And there's a whole other community, very well-established community, with lots of very interesting tasks that are just based on observing humans and seeing what they do. And there are things that you would recognize in your system. There's, I'll just give a couple of highlights. For associative learning, classical conditioning, the system forms associations between a predicted environmental cue and an accompanying stimulus. Now that's a very abstract task, but it's something that's very specific that shows the system can have classical conditioning. Or say social encoding, categorizes self by others and others by salient features of behavior, forms stereotypes and forms a self-schema. Now we had about 10 of these that was starting with an overview, which was for something we were calling a toddler Turing test at the time. There's a whole community we can engage that could give us laundry lists of tests of that caliber. That you could say, and it doesn't have to be you have to do A before B before C. Just put them all on the wall and say, my architecture does these three. And I think I can do that one maybe. And it's a way of categorizing things that we don't have to reinvent the wheel on these tasks.
Sam,
go on.
For a minute. Sam, would you be kind enough to get with Bruce and to put that list on our network that we're going to establish?
Sure.
I think one thing this suggests is that if we do go ahead with the idea that John suggests of doing a workshop focused on identifying tasks, it would be interesting to invite researchers from that community to discuss with us their view on, I mean, in particular, if we're going to follow the virtual world idea, which of these tasks that are used in developmental psychology and developmental neuroscience are ported naturally to the virtual world context for use with embodied AGIs. I guess some will be.
This community is also exceptionally good at developing experiments. So
right.
They'll tell you what experiments would test it or not.
Yeah, that definitely should go in. If we apply for NSF funding, that definitely should go in the proposal. We want to bring AGI people together with developmental neuroscience people and look at the right set of tasks in virtual worlds. I think it's a small subset of the roadmap topic, but it's a very sensible action on it.
If I can make another suggestion, the last one seemed pretty productive. I do not think that I know everything that I want to know in order to build an AGI. So one thing that I haven't seen mentioned yet in the roadmap is the notion of open research questions. That is, not build something that does this, but answer this question. How does this work? Here's something humans do. How are they doing it? For example, I'm very interested in reflectivity. And I'm not really sure I can quite give you a good reflective task unless it would be modeling other minds or something like that. But I would nonetheless like to be able to put on the roadmap something that says, and we'd like to do some research on thinking about thought.
Tasks are necessary for metrics, but there's a very great danger that single tasks immediately lead to narrow AI. one of my interests would be take a couple of tasks that are fairly well solved, you know, take the best solution from the larger, you know, cut the resources by 80% and say, fine, now create a system that does both of these tasks in less resources than this over-optimized, you know, one particular solution. You know, Deep Blue plays chess far better than a human, but it's not general at all. And in some senses, it's almost unusable when you're talking about, you know, artificial general intelligence. I guess I'm really leery about people who are going for, you know, solutions to a single problem and optimizing the problem. You know, in some ways, I want to say, look, vision is not an AGI problem. You know, it's part of our problem. It's one of the things that needs to be solved, yes, but if you're focusing on vision and only on vision, what you come up with eventually either has to be incorporated in the AGI as a single module, which there's some sort of interface to, or even maybe it's going to be useless to us because, you know, it isn't, you know, coordinating with everything else. And I think that's some of the problem we're having as a group here. You know, okay, now we're going back to the 9 million different tasks, 9 million different solutions. Well, at a minimum, I want to see people go, well, let's take that bizarre task and that bizarre task, and at least say you have to do the same of them, both of them together with constrained resources.
I'm not sure. That's an interesting suggestion. I'm not sure that wouldn't just lead to a focus on code optimization and just trying to do things with less resources. Just a meta-level comment is that it is now noon, which is the time at which this is supposed to terminate. So I'd like to, I guess if there's nothing else critical, we should wrap things up now.
All right. Thanks to our organizers.
Really thank Stan Franklin for serving as the general chair of the conference, and Pei for working, Stan and the man. Sydney and Lee for handling all the operations here, and Pei for doing the bulk of the work and getting the proceedings put together. And finally, Bruce for the online aspect. I think it's come off it's actually more fun than I expected it would be. I think that the discussion format worked out well. We got a lot of really smart, thoughtful people. I can say I've never had so many interesting conversations about AGI in a 3-day period. And hopefully AGI-09 will be even better.